Let's find dimensions that maximize area of a rectangular enclosure. Let's get started. So reviewing this problem, a person wants to build a rectangular pen for some farm animals. One side of the pen will be against a barn, so no fence is needed on that side. The other 3 sides will require fencing. If this person has 800 feet of fencing, find the dimensions that maximize the area of the pen using all of the available fencing materials, 800 feet to be exact. The problem goes on to say, let W be the width of the enclosure and let L be the length of the enclosure as shown. Write a function for the area of the enclosure in terms of W. Area in terms of W. We have a barn and we have this enclosure adjacent to the barn. This is our pen. And we were told to let the width equal W and let L be the length. We were also told, as far as the perimeter for the fencing of this pen, we have 800 feet of fencing available, okay? And it only involves 3 sides. We won't need a 4th side next to the barn because the barn is there. Let's talk about how we compute area. Area is length times width. Now let's find the perimeter of this 3-sided enclosure. Okay, so we have to add up all the sides, and all here means 3 sides. W plus W plus L. So we have 2 W's. W plus W. We have 2 sides labeled W. Plus we have a side labeled L. That represents the perimeter. Now we know how much fencing we have. So let's substitute in 800 for P, the perimeter. We were also told in the problem we want the area written in terms of W. So what we're going to do is solve for L. Why would we solve for L if we are trying to write in terms of W? So we subtract W from both sides, and we have now isolated L. 800 minus 2W. Okay, the reason we do that is so that if we see an L, we can substitute in this expression, which involves W. Let's make this make sense. Let's find the area formula. We said length times width equals area. Now in place of length, we're going to substitute in what length equals in terms of W. Okay? And then we're going to copy everything else over. So length equals 800 minus 2W. Now we get to distribute the W to both terms in the parentheses. And we get 800W minus 2W squared, and that gives us our area. And at this point, our area is written in terms of W. We see no L on the other side of the equation. So this is our A of W. That's one of our answers to our problem. The area written in terms of W equals 800W minus 2W squared. Alternately, you may write negative 2W squared plus 800 if you're going to write this in descending order. So speaking of descending order or standard form, this coefficient is the leading coefficient, and that means A equals negative 2. This coefficient on W is B. B equals 800. Okay? Since A is negative, our leading coefficient is negative, what this is describing is a parabola, because this is a quadratic, It's a parabola that opens downward with a vertex sitting on top of that parabola. And that vertex is an ordered pair, W, L. Normally X, Y, but in this case, W, L. And because the parabola opens downward, we do have a maximum point up here, so we will be able to maximize this area. But the key to maximizing the area is finding this point, because any point on this parabola will give us the same perimeter, but we want the maximum area, and that's this point here. So let's go ahead and find the vertex in our next section. So here is the formula for vertex. W equals negative B over 2A. And then we would have to find the L at some point. Negative B, opposite of B. If B is positive 800, then negative B would be negative 800. 2 times A, 2 times negative 2. Negative 800 divided by negative 4 gives us 200. Since this W, this width, is the vertex of this parabola, that is the width that's going to give us the maximum area. So we can go ahead and answer this question: what width would maximize the area? 200 feet. Okay, so now let's go find the length, the other part, corresponding part of this vertex. Okay, so find L when W equals 200. Okay, I'm going to use this formula here, this equation. It tells us how to find L. Spells it out for us. L equals 800 minus 2W, and the maximum width is 200. 2 times 200 is 400. 8 minus 400 is 400. So we know the length that would maximize the area is 400 for this other part of this question. Now, what length would maximize the area? 400 feet. Now that we have the width and the length that would maximize the area, they want us to go ahead and find the maximum area. And that's going to involve both of those values. So area formula is length times width. And if we use the maximum length, 400 feet, and the width that would maximize the area, 200 feet, multiply those together. 4 times 2 is 8. Then we have 4 zeros involved. 1, 2, 3, 4. Then we have feet times feet, which is feet squared, or square feet. And that is our final answer. What is the maximum area? 80,000 square feet.